When an object falls, the rate of change of velocity is given by this expression. K and P are constants. We have to show that the equation, this one, P plus A e to the power minus kt, is a solution of this differential equation. So in order to do that, what we can do, we will try whether this one satisfies the differential equation. So let's differentiate this one, dv over dt. P is a constant, so that will go away. It is minus ka e to the power minus kt. So that we get from here, and then the differential equation that is there is given as dv over dt. So if I get rid of the bracket, it's minus kv plus kp. So instead of v, I can write dv dt. So minus k, and then v is p plus a e to the power minus kt plus kp. So we can see that minus kp plus a, that becomes minus ak e to the power minus kt plus kp. So these two getting cancelled. So this is actually this one is actually this one. So it does satisfy the differential equation. So if we start with this solution and then differentiate, we actually end up getting this differential equation as we have seen. And the second part is P is 500 and initial velocity is 0. So when t is equal to 0, v is equal to 0. And when t is equal to 5, the velocity is 21. So we have to find the value of a and k. So the solution is p plus e to the power minus kt. So when t is equal to 0, v is equal to 0. So this is v is equal to this one. So when t is equal to 0, v is equal to 0. So 0 here, p is 500, that's given. So let's write 500 plus a e to the power 0. So that's 1. So 500 plus a 0, that is a is equal to negative 500. And when t is equal to 5, v is equal to 21. So 21 here, p is 500, a is negative 500, e to the power minus 5k, because t is 5. So we get 500, this is negative, e to the power minus 5k, and this is negative. If this 500 goes on that side, it becomes negative 500, so becomes 479, and then this negative gets cancelled. So e to the power minus 5k is 479 over 500, and then if I take ln, it becomes negative 5k ln of this one, so it becomes negative 0.04, 0.04, and then this negative and this negative getting cancelled. So k becomes, once I divide this one by 5.04 divided by 5, it becomes 0.008 approximately. So that's the value of k. Then we need to find the velocity after 20 seconds. So v is p plus a e to the power minus kt. Now we know both a and k. So 500 minus 500 e to the power minus 0.008 times 20. This one k, we should take two more digits. It's actually 0.00858. So basically I have taken 5 digits after decimal, because there will be a fine difference, because it's on the power of exponential. So that's why we should take as accurate as possible. So let's do this one, point negative 0.00858 times 20, and if we do it, this calculation in a calculator, we get something like 78.84 millisecond meter per second. That's the velocity after 20 seconds. Now finally we have to see, we have to find what is the maximum velocity when t is equal to infinity, t approaches infinity, or we can say after a very long time. So what's the final velocity? So when t is equal to infinity, the expression is this one, and when t is equal to t tends to infinity, this part becomes, this is actually 1 over e to the power kt. So this t becomes infinity, so the denominator becomes very large, so the whole thing 1 over the very large thing becomes 0. So this part, this part becomes 0 when t is equal to infinity. So v approaches 500 meter per second. So that's what it is.